Okay, so I'm in the middle of taking apart all the wiring in this CL20 Mori Seiki that we're going to rewire for a better controller, just for an updated look. And this is what I've taken out so far. You can see the resistors, the brake resistors, the main cutoff, and then you have spindle, main computer, all the boards. Then we have the Z-axis right here. This is a 1.8 kilowatt, and this is the Y, or the X-axis, 0.8 kilowatts. And we have the 24 volt DC to the relays. These are all 24 volt relays, a bunch of them. Pretty awesome. We have the LED lights right here for every relay that comes on, the output and the input. And then we have the probe controller right here. And this is what the probe controller outputs. But mainly, what we'll need are limit switches for the X going in. We'll need limit switches for the Z. And the reason I'm doing this is because this is what the switches look like. So I'm going to put my own Hall sensors in here, and we're just going to wire it up ourselves. Yeah, the wires still look good. Here's the junction to it all, and then we have our hydraulic pressure going to the turret. Spin the turret. We have a sensor that senses each tool, and we have our big motor that spins the turret. Then we have coolant going in there somewhere. There's the coolant, here's the hydraulic. But anyway, these all have wires for sensors and whatnot, and I can just wire that up myself because a lot of this stuff's pretty old. So we're taking this apart, and we have a fuse bus. Fuse bus is down there, but we have the relay, or the mechanical switches right here. But this is the wiring, and you can tell someone's been in here because a lot of these connectors are not as tight. For instance, we'll take off one of these. So this is how tight they are. That's how you know they did their job, because you'll strip it if you're not pushing hard enough. You can hear the crack, it's crazy. You have to push in and twist at the same time. This side, here's the probe controller. All of these wires went to all the relays right here. And this all went to the main control board right there. So these were all the inputs and outputs that the controller received to know what to do, which we'll redo all that anyway. Then we have just connector bars, which just going through taking them all out, because we're only going to put in what we want, and we can have external controllers with a CAN bus system, and then just 4 wires coming back, positive, ground, CAN high, CAN low, and those can just be coming through, so we can sense everything. I'll show you. So a lot of these wires are coming from, I'm gonna replace these with encoders. I mean, these are really good actually. I figured it out after I took them out. You can see the LEDs, pretty awesome LEDs. But I desoldered it and took it out, and I'll just put encoders on here and then simple run it back in. I didn't have a diagram though for all these wire outputs, Then eventually I did kind of find one, but I don't trust it. But I took it apart to read what these were, and you can see we have our A negative, B negative, A positive, B positive. Then we have our power, 5 volts in the back. We have our ground, our Z, and then all the other stuff. But here's our hydraulic. Okay, it's not focusing, but the hydraulic bar. What's going on? There we go. Hydraulic chuck, right here. And we have sensors all around it. We have some right here. We have this one right here. So when it's pulled back, when it's pushed forward, right? And then we have some more sensors. We have some more sensors. I believe. Some more sensors in here, I believe. Oh, those are the same ones. Okay, so when it's pulled back or pushed forward, so we can see with the Hall effect. I'm pretty sure these are Hall effect. SQ5. We'll trace that back in there, and we'll use the existing wiring, but we could also mount a controller in here that takes all this wiring, plug it into that, and then mount that somewhere in here against the wall back here, and then just send a few wires in. We also have all these wires. These don't go, yeah, these don't go that way though. So I believe all these go along the side. They go right here, and they come out, they come out down here, which then goes in to right here. Comes out here. So these are all the switchboard connectors, which we'll use some of those. Not all of them, but some of them. And we can see what the back of that panel looks like. So here's the front. And you can see the back here. Really old display. That's crazy. We have some regular switches right here. We have some LED lights right there, that's pretty cool. It's labeled SA2, so we can see the light is on SA2, and then SB18 would be position record. Our stop, which would be P23 and P3C and whatnot. But all this runs down up into here. So it's just old stuff that we don't really need. A CAN bus controller can take care of all that, plus a new panel. But I kind of like this panel, so I might keep it. Cut the wires, put a little controller in here somewhere, then have all the inputs go into that, and then just have the main board, the K-flop, receive all those signals. So when, for instance, a button's pushed, let's see, what button would we use? Probably the start. So when the start's pushed, right, this will go into a digital input, and it'll pull it low or high, whatever I want it, most likely low. So it'll have power, and when I hit it, it'll pull it low, and then I'll label this as like some kind of name in the software. Like that pin will be start switch or something. And so whenever this gets a message through the 4 wires, the CAN bus, it gets a message, start switch was pushed. It'll know, okay, start the sequence, and then stop right next to it. So that'll cancel it, and then push stop actually disconnects all the power to the drivers, I believe. So it just stops everything. We have our rotary encoder, which this will be our position of where the machine moves, which I'll have a joystick most likely, so I won't be using that, but we could still hook it up just for fun. We have a switch for, the override switch. And I'm guessing that's just multiple switches in one. Or it could be, this could be just a potentiometer. So depending on analog to digital voltage that goes into that controller, it'll mount, right here. It'll output the CAN signal. Just like your car, when you push a button, it has an ID, and that ID goes in, gets to the computer, and then the computer knows what to do when this sees a certain voltage. For the ADC right here, this will be the incremental encoder, rotary encoder. So yeah, we have some cool stuff we can do back here and not have so many switches. That's kind of the goal here, is that these will just send logic signals back for the ones I want to use. Yeah, we can eliminate a lot of this stuff too. Maybe we can put the controller like right here maybe, or something, probably higher up. So we just give it power and maybe take this out and put like an actual display, like a 7-inch, a newer one. So, well, the point of this was just to kind of go over what this machine has, right? So we have a bunch of output wires. So all these blue wires, right, they're all outputs of sort, and they're all going to be linked up together into a ribbon cable all the way down into here, into there, and they'll be secured. There's nothing on the bottom though. Looks like the ones that go together just get pushed together, and then the singular ones just kind of hang out. I don't know if they disconnected them or not, but the machine wasn't working when I got it. But it didn't look crashed at all, so I mean everything looked good as far as I can tell. A2-6 mount. It's pretty clean, not horrible. And so it's just kind of how these machines operated. We have a push sensor right here. So when the door shuts, that just, there's ground right here, and there's probably, a ground up here, and then when this gets pulled to ground, or when it gets voltage, it sends it back to the controller, and the controller knows, the door's shut. And then when it breaks the signal, it knows it's open. There's a bunch of that. There's a bunch of just braking signals or hall sensors. We can see this goes down back into the main loom here, all the way back. And as far as sensors, here's one. Here's one right here. So we can see this rolls up on here. And when it rolls up, it clicks, so it knows, okay, I reached the max this way. And then there's another one of these over there, and then you can see there's one right here as well, and then there's one back here. So we have about, this much travel with this guy. And so we know where it's at. And this would be middle. And there would be a hall sensor right here, or a switch plus a hall sensor. So when it sees this, it knows it's maybe homed because it sees the metal. The hall switch detects the metal, and that's 4 wires or 3, depending on what kind of hall sensor you get. But 5 volts ground, and then a signal wire out. So it's either opened or closed based on if it sees metal. We have a roller switch here, which as it rolls up, it clicks. So it just knows generally where it's at. Not very precise, but it knows, okay, that's max travel. Then we have another hall sensor on the tool change, right? So all those hall sensors lead to a lot of wires, you can see, but they're each individual sensors, right? And it all boils down to, you know, how much control you have. So a bunch of relays that we'll get rid of. We can do solid state for these. We have some more bigger relays right here. And just turn stuff on and give stuff power, which we'll replace. We have some relays here for, you know, coolant. For these are probably for the hydraulic pump, for the coolant pump, and then for various things like the fans. There's some more fans back here. Oh no, another one right here. So, and then we have our main transformer. So that'll give us voltage for everything. So we have 100 volts, 80 volts, and I don't want these to break, but you know, 30 volts, 20 volts, whatever. So this gets the main voltage right here, 250 volts, 110 or 120, 120, then a ground. We can kind of see, yeah, 240 volts, 200, 220, 240. So I believe my voltage is 220 because it's 110. So that's correct for me. So I'll leave that if I do decide to use this. We can see all the outputs to that motor are right here. A bunch of connectors to those relays. And then we have a bunch of red connectors that went to the bottom of those relays. We could look at those real quick as well. So when we control a lot of little things, and I could tell someone messed with it because some of these screws were loose. Like, I've not messed with these screws, and I'm noticing that one's loose. That one's on there. That one's on there. That one's on there. So maybe they were attempting to take it off. But we can see the relays. So we get a logic level signal in, and it activates this small coil. And then we get a big signal out, which we could just replace this with IGBTs, but for now, I'll use these. Oh, hey babe. How are you? Oh, you waved. Oh. And we have all of our outputs here. Most of the outputs. I'm not sure if I'll use this because of the cabling. Oh. Here's the encoder. Oh, hi, babe.
Here's the encoder.
Yeah, I forgot what it's called. And here's the board for it, and the LEDs that go to it. And then this picks up the light that goes through it. And I won't be using any of this anymore. And that's about it. When it oh, here's the solenoid. So those relays will control these solenoids. Here's one here. And I think this is for the turret. And then there's one on the other side for the drawbar for the